Hi, Assalamu alaikum. Welcome everyone to today's session. In today's video, we are going to explore some discussion on why we build panel data models and how they are evolved. What is the basic background in panel data regression? Before that, if you need to understand what is regression, so I have shown you the link of my YouTube channel where I have searched add a query of regression, and you can see there are several videos which you can explore regarding background of what is regression, and so that when we are studying this video we will be learning what is panel data regression. So I will be sharing a link on the top of the video at the start where you can have this link as a go-to link so that you can have a look at the background on multiple regression, simple regression diagnostics, and why we do regression, what is multicollinearity in regression, what is outliers, simple regression in Urdu, and some other software related regression videos, how regression helps in decision making, so on, time series regression and diagnostics. So now we're going towards our example that we are going to do as a case. So I will start discussing this case in this video. So I have collected data for these variables from World Bank. The data is consumption as a consumption variable, income, prices, broad money, government expenditure, gross savings. So these are some variables. I am going to develop a model of consumption expenditures, and then there are some independent variables. So this is a model where I think the most of the variables are available on the World Bank so that I can make a panel data model. So for that I've written the equation. So this is also called the stochastic equation where there are coefficients and error term. So in mathematics there will be no error term, and this will become a mathematical equation if I give the values of A and B, B1, B2, B3, B4 and B5. So this is a stochastic or a statistical equation. Then we'll talk about the sample. So I've collected data from 1970 to 2016 for these 30 countries as an example. Okay, now I go towards that. If the data is balanced, what is meant by balance? Balance means that each country has equal number of years. So number of years are 46. 1970 to 2000 are 30 years, and then 2016 is 16 years. So it's 46 years. So how many observation there will be? 46 multiplied by 30. So this will be the sample size. So how many? What is the unit of observation? So in a panel data, the unit of observation is mixture of two things. It will be country years. So each observation is a specific country and a specific year. So you can write country dash years or country years. So what is the difference between a behavior model and equilibrium model? So when you start a panel data model, you need to understand what kind of model you are going to estimate. So if your dependent variables are, if DV is a financial variable like GDP or interest rate or money supply with units with or currency growth or currency percentage as units, then it will be a financial variable. Otherwise it will be a social or behavioral variable like infant mortality rate or unemployment rate or poverty rate. So when you are making a panel data model, you need to understand before at the start that if your data is financial variable, then they're highly likely that it will go towards equilibrium model. And if it is a behavioral variable like infant mortality rate or poverty rate or crime rate, it will mostly go towards behavioral model. So why I am talking about that in the behavioral model, in behavioral model, mostly cross-sectional specific post regression issues dominate. And in equilibrium model, time series specific post regression issues dominate. So it means you try to make a model. If it is a behavioral variable, you will try to make a model that is addressing most of the cross-sectional problems. Like people use GMM, or they'll use instrumental variable regression, or they will use static panel data models like fixed effect, random effect, or any other similar type of models. But if the model is equilibrium based, it means the effects are affecting across time. So in future and past are affecting each other. Then you will notice that the time series specific diagnostics are more dominant. Then you will notice that the models that are used are panel ARDL, or systematic GMM, or advanced models of GMM like Arellano bound and Blended bound models. So this is the way you decide what kind of advanced panel data model you are going to select. If you can differentiate between these two things, what is an advantage that you will be able to find an appropriate model very quickly. Otherwise, you have to do some diagnostics, hit and try, and find the model. So we'll start with, is there a need of panel data? So I will share some evidences why we tend to go towards panel data. So let's consider a case of 29 countries for 2 years. This is the model for 2015 for 29 countries. These are the results. Consumption as a function of income, prices, government expenditure, and saving. And then same model for 2016. So 29 countries, similar countries. So what is an interpretation of intercept here? It is a autonomous consumption, and its units are same as the dependent variable. So if you do the comparative interpretation, you will notice that most of the coefficients have similar signs, especially for the income. And can the estimation be connected? So theoretically, these two equations are cross-section equations, and can they be connected? If they are connected, then it means the two equations have some connection with each other. So how we can do? We can go towards and we do the test on it. So what I did, that I generated the residuals, both of the models, and plot a scatter plot. Okay, so the scatter plot has shown a positive slope. Positive slope means that they are highly correlated positively. What is represented by the scatter plot between them? So it is representing their connectedness, or the what you call it, uh, effect of past on present. Okay, so there is some connection. So if you found that there is a connection, why don't we join them together? If we join them together, we will have more information. Like there is only 29 observations here, 29 observations here. If we join them together, we have double the sample size, and we have another information that the models are interconnected. So why don't we add them together? So what are the reasons that necessitate the panel data models? Larger sample, more efficient results. So what we do is, we now on the other side we consider two countries and make time series models. Now if consider this is a model for Pakistan, and this is a model for, and then we did the Durbin-Watson statistic, and then there is a model for India. So in both cases you found out that the Durbin-Watson is not nearing 2, so there is autocorrelation. So these models are autocorrelated. It means that the residuals are showing us that the past residuals are affecting present residuals. So the models are currently not valid. So how we interpret the intercept here? So now you need to notice that in the cross-section regression, the intercept is the effect of other variables which are present across cross-sections on dependent variable. Here it is intercept is effect of other variables which are changing in time, affecting Pakistan and affecting India. So now intercept is affecting, here intercept is picking up the cross section specific variable which is changing in time. Here intercept was picking uh, the time specific variable which are changing across countries. Okay, so the difference is, so this is a model is a cross section, so it is picking, so we can simplify it as that this is a cross section model. So this intercept is picking country specific effects of each country and giving them as an intercept. Here in this model, it is giving us time-specific intercept for Pakistan only. So the intercept is now picking up some different identity or different quality or different other variable effects. So this thing we should be careful of. So these models are correlated, so intercepts are done. So now we plotted their residual. We found out that there is a weak relationship between two residuals. The same reason that the model can be there is a spillover effect as both countries are neighbors to each other, and similar theory pattern, or what you call it, generalization. The theory that you picked is similar in both countries, so you end up having residual which are correlated. So we do not have very high correlation because the models are not fit anyways. So they are also have high autocorrelation. Okay, so there are several other tests in the discrete precisely which can prove that there is a need of parallel data models, specifically advanced ones other than the pooled OLS. Further, both scatter plots prompt that these equations are interrelated. That's why we don't. Then why we don't estimate them simultaneously? Because the reason is that it will have a bigger data and more what we call it, more efficient estimates. So we start towards now talking about, so as a business graduate or a person who is doing research on questionnaires and he's coming towards secondary data, he will ask question that what is the difference between panel data and SEM. So SEM also estimates equation simultaneously, and panel data is also doing it simultaneously. So I have, based on my experience, differentiated some of the differences, but in some cases there will be very less difference that you can recognize. In some models is used when there is simultaneity, means that the equations are interconnected, the source of data is same, the respondent is same. In panel data, yes, there is also simultaneity. In this case, the theory may be same. So here it is because of respondent or unit of analysis, like it can be a firm or analysis. And here simultaneity is because of country same or theory which is interconnected, or what we can also call it spillover effect. Okay, so these are some reasons that can create simultaneity. So in mostly the dependent variables are different. In SEM you have multiple equations where the dependent variables are different. Multiple equations like mediator models or moderator models, and their advanced types. But in panel data, the dependent variable is always same. It is same equation over time or over cross sections. So it doesn't mean that there can be different dependent variables. So if in a panel data there are different dependent variables, we can use the Shore regression method if equations have different dv. So it is a type of SEM, but it is for the secondary data set. So seemingly unrelated regression equations, or okay, then it is used and when it is used when it is assumed that residuals are same, but intercept and slope are different. So, but you are saying that the same different equations, the residuals are interrelated. So they are connected. They have correlation with each other, but for each equation there is a different intercept and different slope. They don't have same. But in this approach, residuals are same, but intercept and slope can or cannot be same. So it's like in fixed effect, in FE or RE model, intercepts are different, but slopes are homogeneous across all the time periods or cross sections. Okay, so I corrected. So here independent variable for each equation can be different. So if you have a same model and there are three equations, you can add different independent variables. But in panel data for all cross sections and non time periods, independent variables are always same because the dependent variable is same. SAM focuses on structure of simultaneous equation. It focuses on how the structure is coming together, how the mediator and moderators are related, how the what you call it, the paths paths are paths are determined from item of IV to item of DV. So you calculate paths, but in focus on integration of data to confirm presence of to confirm generalization of theory. So this is what we do in panel data. So I hope I have given some examples. Now, what are the merits? It's a solution of simultaneity, both of the cases. It's a stronger base of theory to avoid micronumerosity. Micronumerosity is a problem of small sample. So if you make a panel data, you will avoid the small sample problem. Larger sample might help solving problem of non-normality because of central limit theorem and may become robust to outliers. So larger sample, you can use central limit theorem to assume the data is normal. Wider area of models can be selected, focusing on cross-section specific or time specific models. So now we'll start towards the section number 2 and we'll start with basic panel data models and then we'll discuss what are the problems and what are the solutions. So first of all, we make a simple pooled OLS model. So in the pooled OLS model, we assume all countries are homogeneous in all forms. They are similar to each other in all forms. So we mixed the data. So we mixed the data and run it as a big cross-sectional data. So the Stata does not know that it is a panel data. So we ran the model. The data observations are very big. R square is also good. F test is significant. All the variables are significant. So we made this model. What is an apparent difference? First of all, the coefficient values are becoming smaller. They are corrected. And what's the difference? Most of the variables are significant, and the results are better. The R square is bigger. The RMSE might be smaller if you compare it with the previous models, and F test is also bigger. So why it is called pooled OLS? I already explained it here. And we need to check list. So we need to check for diagnostics. What are important? We need to make sure that there is no multicollinearity. There is no autocorrelation. Data must be normal. There must be no hetero specificity. The model should be not be misspecified. And there are other problems like no endogeneity. And the model must be, and there are many more, but we will discuss that later on. So first of all, we'll start with multicollinearity. So there's a command called lmcol in Stata that you might have to install, and so this gave us eigenvalue, C number condition index, C number, VIF, partial tolerance, and partial R squares. So VIF is less than 2 and tolerance is bigger than 0.1. So according to Gujarati, there is no multicollinearity. Now we test for misspecification. So for that, the test is called over identification test. It is significant. So model has omitted variables. So there is misspecification problem. Then we do the normality test on residuals. It is not normal. Check for time series heteroscedasticity. It is, there is hetero in it. And we can check for cross section hetero. There is no specific command in Stata. What we can do is we can add the cross section dummies in the data, and if they are mostly significant, then it means that there is cross section hetero. So this is the numerical way, and you can also do it using graphical method. That this is a command that you can run regression for each cross section and then plot the line. You can notice that each line are parallel. Why? Because the slopes are same. Only we are allowing intercept to differ because of this dummy variable. So since the lines are not placing on the top of each other, it means there is intercept heteroscedasticity, which is representing, and intercept is because of cross section, so there is a cross section hetero. So then cross section articulation that can be used to using XTCD. This is also called cross section dependence. So there is no cross section dependence. Now for the case of time series autocorrelation, the Durbin-Watson is only shown for time series data in Stata. So we can do it manually. What we can do, we can generate residuals and correlate with lag of residuals and then make a plot. So you can notice that the lag and present residuals are positively highly 0.97 correlated. So it means there is autocorrelation. So these are many problems. Okay, so what is the difference between time and autocorrelation? Time autocorrelation looks for past effects, and cross section is actually the spatial effects or the spillover effects or cross section dependence. Then we go towards fixed and random effect models that are first in the line of solutions that we people use. So why we using? Because we notice that first of all there is a problem of cross section hetero. So we come towards this and we found out that when we plot the dependent variable across cross section, there is no homogeneity. Okay, so this is the command that can generate this graph. So this means that the dependent variable is not same across cross section, so we cannot estimate pooled lawless. We need to make sure that it is a model where intercepts are differing across cross sections if we assume that our theory is homogeneous across the model. So we use xtsetid command, which will help us to tell Stata that it is a panel data. And then if this, sometime it will not work because our country name is alphabetical, so we'll have to encode it, then run xtset. Then we go towards the next setting. So I will move it up, fixed effect model. So what I have done is I have generated the fixed effect equation. So same sample size, and then you can notice that all of them are significant. Now what is the difference? That the intercept is varying across cross section. Okay, so when you go done, so this is a test which is checking that if intercepts are equal across cross sections. It is not, because it is significant. So we confirm that we cannot use pooled OLS. Then we move forward. So fixed effect is the one. Then there is a random effect model. This is another way to estimate cross section differences. So when you notice that it assumes that our independent variable and the cross section should not be correlated. So a random effect model should be used when the cross section differences in the intercept are not related to the theory that you are going to estimate. But in the fixed effect model, there can be a correlation. Here it is 48% correlation. So what is the difference between fixed and random effect model? So I have tried to find few differences. This model assumes that the cross sections are quantitatively different, and random effect assumes that they are randomly or qualitatively different. It makes intercept heterogeneous to fully incorporate unobserved heterogeneity. So unobserved heterogeneity means the differences in the countries after the theory. It solves the problematic portion of the unobserved heterogeneity. It does not add the dummies, but it looks at how much the differences are, and adjust the model accordingly. Since it has fully removed the problem, so it is consistent approach. So there is no scare that the model problem is still there. Since it solves the problem partially and keeps the other information, so it is an efficient approach. So it does not remove all the information that is there. It only removes the problematic portion. It allows cross-section differences to be correlated with the dependent variable. It because the differences are random, so it is uncorrelated. So what we do is we need to now talk about which one is better. FE, which is consistent, or RE, which is efficient. So for that we use, first of all, we'll make sure that RE is also better than pooled OLS. For that, after RE model, you have to use this command. If this is significant, it means the random effect model is better than. If significant, RE is better than pooled OLS. Okay, then we go towards Hausman test. It is used when we have two competing models where one is consistent and other is efficient. So we do Hausman consistent model versus efficient model. So if insignificant, then what it is mean that consistent will be equal to efficient. Okay, so we can use the efficient model because the efficient model also has the consistent property. So the RE model has two properties. If significant, then consistent is not equal to efficient. So it means since consistent property is more important, we will use FE. So this way we select the model. Now since the FE model is selected in our FE model is selected in our case, but it will use that we will now do the diagnostics. So FE model we will now check for cross-section hetero. There is cross-section hetero. For time hetero, what we can do is we can add time dummies and have a look if the time periods are significant, or what we can do is we can do a walled test on time dummies. If it is significant, then there is time series hetero. How many new variables are made? The number of years are equal to number of new variables. How we can interpretation these? So each variable is explaining the time dummy effect on the dependent variable. So majority significant, what does it imply? There is time heterogeneity. Time series articulation, XT serial, cross-section articulation, XTCD, residuals, and it is insignificant. So there is time series articulation but not cross-section articulation. Normality, so the normality is still there, in data is not normal. Misspecification, the command is this command checks for panel data normality, so it is not normal. Okay, so these diagnostics help us to go towards advanced models. So okay, so I have noticed that there is time series autocorrelation and time series hetero. It means the data is long in time periods, so it is dominating in terms of time problems, not cross section problems. So it should be an equilibrium model rather than a behavior model. So this way you can identify your advanced models. So now what we'll go towards merits of using fixed and random effect model. So it will solve the problem of missing specification bias, and you can also estimate the intercepts for the countries that are used in the model. So if there are 20 groups, you will get 20 intercepts that can estimate some aspect of behavior in your country. For example, it is talked about that since the consumption is a model, this variable affecting the type of food available, or it can be the culture of the country, how they eat food. So you can technically create an index of quality for all variables which are consistent in time but changing across countries. So it means when you create a fixed effect model, when you generate a cross-section dummy, the dummy is actually showing the property of that country which is not changing in time, but it is different across countries. So you can create a new type of dummy variable from this method. So this is one of the good advantage of fixed and random effect models. So if you add a dependent variable, and you first of all clarify the theoretical determinants by adding independent variables, all that is left will be the country specific characteristics which cannot be measured using independent variables or quantitative variables. So you club them together in a dummy variable or an index, which is not dummy anymore, it's a quantitative index. So that will help you to split the dependent variable into country generic coefficients. So this way you can specialize this method to generate new variables. Similarly, there's an advanced model called random coefficient model. So it will be used if your theory is not homogeneous across countries. So what you can do is you can allow for slopes to change across countries. So XTRC. So when you run it, it will give you first model, and it will tell you test for parameter constancy. So it is significant. It means the coefficients are also changing across time. So I've also explained what parameter constancy means. So when you run it, it will give you coefficients for each country. So this will behave like a model that is estimated across cross sections, then clubbed together as a whole model. Then there is another model that is called feasible generalized least square. You can also find its video in my YouTube channel. So this model is used when you are not able to solve the cross sectional heteros or autoplasticity and autocorrelation. So if there's a problem that's still there and the time periods are not long enough, it means if your model is behavioral, and then and there is this problem, you can use this XTTLS model and then make your model robust to autocorrelation or heteroscedasticity. So then you can compare different assumption models and see how coefficients are differing, and then select the model which has best suited or least root mean square error. Then there is a panel GNA model if there is endogeneity. This is a special case that endogeneity is not usually checked in every model, but if there is endogeneity, you can use XTIV-Rec2 and you can control for endogeneity. There are 4 extra tests: and under identification, weak identification, Sargan, and endogeneity test. Ideally, first two should be insignificant and next two should be significant. So that first two should be significant and next two should be insignificant, so that the model is fit. Then there is a panel SEM. This is a new case of model when there are multiple equations which are estimated in panel data. You can run it using panel SEM. The difficulty in that model is that this SEM is not same as this SEM that we discussed earlier. This is SURE regression, sure, seemingly unrelated regression. So I have equated two equations and added cross-section dummies to make it panel SEM. So this table will be very big if there are too many countries or too many time periods. So this is the model that you can use if you want to estimate simultaneous equations which are in panel data. Then summarizing that, if t is less than 20 and n is high, then you can go for wide panel data models which are behavioral models, and if t is large, then you can go towards equilibrium based models like panel ARDL. If still there is multi-collinearity, you can add cross products and moderators that can solve it, and non-linearity. If you can add dummies to solve for problems. If the dummy is dependent, you can go for panel logic model, or if the dependent variable has limit, panel Tobit, and if the panel dependent variable is discrete, then panel Poisson or negative binomial regression. And if there is still multi-collinearity existing, then you can go for panel data version of rich regression. So this is a discussion, and I will show you these commands on the screen. You can use my another video where you can copy these codes through the video to recreate what you want to do it. So I'm slowly moving it, so you can pause and copy the code or type it. So this way you can learn why there is the need for advanced panel data models. So this video added different discussions of different types of diagnostic problems. I hope you like this video. Do share it to others so that they can learn how to make panel data regression and how to build towards advanced models. Thank you. Bye.